Alright, today we're going to try to finish up with some of the basics of the sketch-based features toolbar. After the multi-section solid hour and a half, I'd really like to keep this one a little bit shorter. I'm sure you would too. Really, the main one I want to talk about is right here. So if I pull this out, the whole tool. This is what I would say is one of the the main handful of commonly used tools here. Like I've mentioned before in other videos, I'm trying to avoid going through like everything in every single submenu, everything in every drop-down menu of each item here, just because it's there. I want to stick with the overview feel of this. So I'm going to hit the whole tool. I will go over the solid combine because it's real quick, fast, and we don't use it very often. I can just knock it out of the way. You'll see in a minute how it works. It's cool. You'll probably like it. You'll probably go, oh, well, that's pretty interesting. But just trust me that there's a thing called Boolean operations that we'll get on later that does the same thing but with a lot more options. So there's that. And as far as getting to everything in the subtext down here, if we have enough time, I'll probably try to knock out some of those pretty quickly also. And then we will be done with the CATIA fundamentals sketch-based features, and that's kind of a wrap for this whole entire section here. The next thing after that will be over here, will be the dress-up features. Okay, so let me just sort of stash that out of the way there. I have this disk already pre-made. It's just a pad. Just look over here. We got to have some kind of an object created first, because without it, you can't make a hole. I'm sure I'll do a video on this later. There is actually a way in CATIA that you can make a hole, or you can make any of the negative features without having anything solid first, which is really a little bit of a brain fry, because it's kind of like you make a hole in space, and then what ends up showing up is actually a solid instead of a hole. It has to do with what they call positive and negative part bodies, or part body polarity. It's really pretty interesting. I can't say that I functionally ever use it, but that'll be something we talk about. It'll probably tie in best with when we go do Boolean operations. I think the first thing to probably understand about the whole tool itself is probably when to use it. I would say that people, when they're first getting started, they make pads, they make pockets, you make a sketch, you cut it through, pad it up, whatever you want to do. With the whole tool, I think people look at it as it's seemingly a convoluted tool to ultimately get the same effect as if I were to just put a circle on the face of this and pocket it through. So kind of knowing when it's a good idea to use it and when not. It probably, I would say, really depends upon the industry that you're in. So let me give you a quick overview on how this tool is going to work. Basically, you come over here, you hit the icon, and typically before you hit an icon and then something happens, right? In this case, you hit it and it turns orange, and we're sitting here waiting, for the window to pop open. If you look over here, follow my mouse, if you look down here in the corner, there is a bit of a status bar down there that will tell you what you're supposed to do next. And so it's saying select the face or plane. So in this case, it's kind of like Sketcher. You pick it and it says, what plane do you want to put this on? So I go ahead and I'll click right here, and then this dialog window pops up. Keep in mind that what's happening right now is we're not clicking where we want the hole to be. Initially, you're just saying, I want to put a hole on this surface. The moving it around, the positioning of the hole is going to come up here in a second. So in the dialog box, just initially it says, is it going to be a blind hole? Like in the other windows, it would say dimension, but this is just what they call it in the hole tool. It's going to go through a certain depth, but you won't be able to see through it because it's blind, I guess you'd say. Up to next surface, up to last surface, up to plane, up to an actual surface you pick. What diameter do you want to make it? How deep do you want it to go, right? The thing that I'd recommend just get in the habit of doing first, it seems like in class for students, it's the one that they seem to skip, and it sort of causes confusion, I guess, is you want to go right away to positioning sketch. So it's kind of like a little sketcher button inside of the hole tool. So you hit this, even though it looks like we're in Sketcher right now. If you look at our tools over here on the right, we're not. You hit positioning sketch. Now we're in Sketcher. We're not going to draw a shape. What we're going to do is you're going to take the asterisk over here. You're going to move it somewhere, wherever you want it. And then you exit back out here and see that's where it's going to position the hole, the center of the hole. Then you change the diameter, change it to 2 centimeters, I guess, for a depth of, you know, that much, I guess. Hit OK, and there's our hole. Okay. I can come back here and I can edit it, and I can say, no, I want to go up to last. Hit OK, and it goes all the way through. That's the basics. Okay, let me undo this and get a little bit more detailed with it. Alright, so we come over here, and you can pick the icon or you can hit the face first, right? We'll hit here, go to the hole tool, this opens up, and we'll go to positioning sketch, and we'll move this around, say, over here. The problem with obviously just moving around is it's not very accurate, so you'll want to constrain it. Say I want it to be, well, I have a number, let's just say, over here. I pick it and I go to constraints, and I say I want this so far away from horizontal. So if I'm going to do Cartesian like this, then I have to, you know, say so far from horizontal and so far from vertical. So I'll go ahead and pick this here and there, and then I could say, oh yeah, here's what I want. I want it 2 centimeters away from horizontal and 2 centimeters away from vertical. So that's pretty much the established plan there. If you wanted to, let me undo all of this. I mean, you can constrain this however the heck you want, but you can do polar constraints, which would be going from here to, say, origin for the center there, and that gives me a constant distance from center, and then I could set up an angle. But in order to set up an angle, we have to have a line. So then you could say, okay, well, I'm going to take a line from here to there, right to center, and make sure that you make it a construction line. And then you can say, I want this maybe, you know, 35 degrees off of horizontal, go in this direction. And then that turns green and it's fully constrained. So however you want it, you get it into the position that you need it to be, then you can exit out, and now at least we're solid with the center point of our hole. Okay, so the next thing we want to do then is come over here and start changing our diameter and depth. So let's say we just want it 5 millimeters. Oops, I hit OK. Get back here. 5 millimeters, half a centimeter, and it's a blind hole. Went back to that. Do I want it to go up to last? Sure, let's go up to last. Hit OK. And then there's our hole. Again, still feeling a little bit, you know, like a lot of extra work rather than just going to a sketch and making a hole. But now, let's say I want to do a couple more things to it. So I come back here and I say, well, I know that they want this to be flush mount, so when they put the fastener in here, they don't want anything sticking out, so we want to make it a simple hole. Look over here, watch this. This is kind of your guide to what it's doing. This is just a hole drilled all the way through. I go, oh no, look at all of this. I want it tapered. So see what it does here. It'll taper it at the angle that we choose, and you can see that it's describing it here. I say OK, or you can just hit preview, and there's our angled hole. And we're like, wow, no, that's not really what I wanted to do. I thought I wanted an angle. Oh yeah, I want it countersunk. Okay, so countersunk, and hit preview, and you can see what we're going to get. And then you have to change everything here. So you go, okay, well, I don't want it half a centimeter deep there. I want it maybe like 3 millimeters deep. And the angle, maybe I want it to be 118, 120. A lot of your fasteners out there will have like 118 degree angles on the counter sunk heads. and you hit preview, and you're like, okay, well, I think that's what I want, and then you hit OK. So this is kind of the reasons why you might want to use the hole tool. It's not because you just want to make a round circle pocket all the way through. It's because you want to add all these other features. I've described this a lot as being kind of like a macro of sorts. You could make a pocket it all the way through. Then, we haven't talked about it yet, but you can come over here and you grab the chamfer tool, and then you could put an angle on the edge. If you wanted to make it counterboard, then it would be like make a pocket, make a circle, pocket it all the way through, then make a bigger one and pocket it down a little bit. Right? Then there's this neat thing called counter drilled, which is counter sunk and counterboard. So in this case, it would be something like, okay, make a circle on the top, pocket it all the way through, make a bigger circle, pocket it all the way down, and then on the edge of that circle, put a chamfer on it, but it's not a 90-degree chamfer, so you'd have to play around with the angles to get it to match right. And now we're starting to look at a lot more effort where this becomes the useful tool, the one that we want to go for. Okay. Now this is a pretty nice segue into what they call DFM, or Design for Manufacturing. It's kind of an obvious thing in the world of acronyms and all this, you know, Lean and Six Sigma and all these other things for just, you know, kind of normal operation life in a shop. What they're saying is we need to make our design, make our CATIA model, do whatever we're doing, make sure that we can make it. Make sure that the shop can make it, maybe even conveniently. How about this? Make your designers, or you as a designer, communicate with the people in the shop. Go talk to them, hang out with them, right? And so then what you find out is things like, well, I can make a hole for this fastener, but I need to you know, make sure that there's an actual fastener that's going to go in here. And you could look at the data sheets for sure, or you could look at the rough idea of it. You could say that it's an M5 countersunk, maybe, you know, 10 millimeter long fastener, and you could go off of that. But I would suggest that you actually go feel it, touch it, see where it comes. You know, how, each manufacturer might have a couple different things about it that are a little bit different. And you can check here on the Wikipedia, you can see how different manufacturers will make different angles on their countersink, and you'll have to accommodate that. You might even have to call in as an engineering meeting and maybe talk about how one countersunk fastener head is going to hold better, have more bite of material than another, let's say, right? Now there's another thing that I just want to mention here too, is that I will go to the store and I'll buy a countersunk screw, but if you look at this picture here, you'll see that the angle on the edges of the countersunk, the top edges here, they don't come to an infinite perfect sharp point. They always tend to be a little bit rounded. And so if I just went by the angle and assumed kind of like a digital model perfect, you know, sharp flat fastener here, I might end up with a problem. So what I'm getting at here is I'll take this and I'll change it back to a countersunk hole here. If we look at this, I don't really think there's any fastener I've ever seen that will fit in this hole like this just perfectly and be absolutely flush mounted, unless if we were to look down on it, if the fastener was only, you know, maybe this big, and we could get it down deep enough to where it was flush, and then we'd have all the wasted space, if you can see what I'm talking about. What I do is even if the fastener itself is just plain countersunk, it doesn't say it's counter drilled, I make pretty much all of my holes for countersunk fasteners counter drilled, and I'll say the depth here might only be like maybe, you know, 1 millimeter, right, just like that. But if the diameter of the head is, you know, 1.5 centimeters, I'll drop it down just that tiny little bit there, just so I can get the fastener to go in perfectly flush. Right? So let's talk about some of the other features here. Well, really the only one left is the thread definition, and this is a deal. A lot of the CAD programs do this. I really wish that CATIA would maybe change this. I don't have 3D experience yet. Maybe it's possible they are doing something with this, but here's kind of my thoughts on this. So this is just a little bit of a rant. I can hit threaded, and I can pick a standard, but they don't have any US standards in here, imperial, fractional, whatever you want to call it. Just the metric. And most of the time you're going to be putting in your own stuff here anyways. That's fine. Fine, right? So you hit OK, and the deal here is it doesn't show them. They're not really there. And they did this to for the performance of CATIA, and because computers, maybe especially in the older days, were weaker, to have to visualize the threads here, that's going to be a pretty high polygon count. So they chose not to show it. I really wish there would have been a button that says, hey, click, go ahead and show it, because I got a pretty good computer. Because here's the problem. Maybe in the older days, prior to 3D printing, you could say, okay, the holes are there, and we have other tools that you can go to that you can see that it is threaded. So this is the thread tap analysis, and you go, oh yeah, show me the threads. Oh, it just shows me that apparently I told it to be threaded there. Yeah, that doesn't help me a whole lot. If I want to send this to the 3D printer, it will not print threads. So this the rant becomes larger. If I have to make a threaded part in the 3D printer, then what I have to do is I have to go into, there's a tool in surface design that's absolutely wonderful. It's called a helix, and it will let me make a spiral. Say for example down this hole. I make the spiral, but it's just a thread. Then I have to stick a triangle or something like that on that line, and what I end up doing is, if you remember the rib tool, I'll take that triangle and have it follow the helix down, and then I'll get my thread. But what pitch do I make the helix at? Well, I've got to bring up the data sheets for actual thread. So then all of a sudden I leave being a designer. Now I have to go be a machinist, and that's fine, I guess. Maybe you probably didn't want to do it at the moment that you were trying to make these threads, but you have to figure out what are the standards of threads that you're using in your industry, and how do you match them up right? It's quite a bit like gearing, like gear lash, and how tight do you get them to fit together? How loose do you make them just so you get a good snug fit and it doesn't wobble around, etc., etc. So that becomes a little mini nightmare in itself. Now, CATIA does have an NC toolpath creation workbench. I've messed around with it a little bit, but honestly, I have other toolpath creation software that I use that I like better. Maybe some could say I just didn't give CATIA a chance, but there's that. But here's the way this whole thing kind of shakes out to me. If you're watching these videos and you work for a large company, has lots of money, has an extensive machine shop, and you have large machines that have tool changers on them and with threads or tapping tools, sure, that's fabulous. But well, if we start from scratch, it's like, well, what kind of a CAD program are you using? Everybody out there in the world, is like, what kind of a CAD program? Well, I guess I'll go with CATIA. So who can afford CATIA? Well, not too many people just on their own. They're probably going to be working for a large company. But let's say you foot the bill for CATIA, tens of thousands of dollars, by the way. Okay, so you have CATIA. Now, do you have CNC machines that do you have a machine shop? Maybe, sure, yes you do. Does that have a tool changer? Maybe, maybe not. Probably not. So you're probably going to be doing it, tapping these things by hand. And so it becomes kind of a point of whether or not, do you really need to use that tap system there, or would you just do it by yourself? So honestly, after all is said and done, the thread tap function here, there's also this tool over here where you could thread or tap any hole that maybe you did another way. Like say you made a pocket, you could tap it. Because of the way the things that you'd have to have in order to take advantage of this, like a tool changing CNC machine with tap ability in it and all that, you know, most of the time I just opt for skip the threads, make the hole, and then tap it by hand after. Okay. One little piece to go along with that, look up the chart for holes, threads and taps. For example, if you have an M5 hole, if you have an M5 fastener, you don't make an M5 hole. If you make an M5 hole, the fastener is just going to drop in. There's not going to be any meat there, any material to make a thread with. So you'll find a chart, for example, an M5 would be conveniently a 4.5 millimeter hole. And so you start to get used to that as a designer. That's your DFM. That's your designing for manufacturing. I'd even go so far as to say design for maintenance. Design for everything you can think of that's going to be helpful with the person next down the road. So anyway, so make sure that you have that chart handy. M5s, 4.5. There's also decimal conversions as well. And then life is good. I like the idea that you can make the holes in CATIA and then make them on the mill rather than a drill, because drills tend to come in certain sizes, like what I just said. An M5 fastener will say use a 4.5 drill to make the hole and then tap that. They say that because they have 4.5 millimeter drills. When actually, if you look at the best possible fit, you might determine that actually if we make the hole 4.435, let's say, millimeters, we'll have just a little bit better fit, or undersize, or whatever. Okay, so more practical work that you have to do here. But other than that, that's the whole tool. Nothing real complicated there. Let me delete it, and I will do it again from scratch. Alright, so we'll whip through this again, pick the face, go to the hole tool. I would say right off the bat, go to positioning sketch, get this moved where you want it to. Oops, that becomes kind of a problem sometimes. Move that over there, constrain it however you like, and exit out and start setting up the hole. Say this is going to be just an Allen head screw. Maybe we find out that the diameter of that is maybe 4 millimeters, like an M4, and the depth 0.8, just not quite all the way through. The head is not nearly that big, so you come over here, counter bore. You get out your calipers, measure the thing. You might find that it's actually something like 0.6, 0.65. And then measure the depth. Make sure you give yourself tolerance. Don't measure it exact. A lot of times it doesn't matter if you bury it a little bit deeper. So we'll make this one 0.35. That looks like an Allen screw. And uncheck this if it's checked. Hit OK. There's our hole. Okay. Nice thing here too is that it doesn't break all this stuff out. It's still all contained in the hole tool. So if you ever want to come out and edit it and you say, no, I want that to go up to last, easy enough. It's all there. One more time. Here, sketch, position, exit out, up to last, diameter 5 millimeters. Countersunk. Okay. Alright. So, no biggie there. I think the biggest of the deal is, you know, when do you use this? When do you choose to use this? Because it would be usually a little bit more, or a lot bit more tedious to use a pocket and extra features. Okay, so how much more difficult would this be? Well, click the surface, make a hole, up to last, 1 centimeter, simple, here, sketch, move this over, exit out, there. Okay, so there's that. Now I pick the face, go to Sketcher, and I grab a circle, and I put it right there, and I exit out, and I say pocket, oops, up to last. Great. So which was easier? Counting clicks, probably, you know, the pocket's probably real close. As far as, you know, pain in the ass quotient, I guess, you know, I think the whole tool is a little bit more, you know, clickety click, more things you got to do there. Okay, so do this. Pick here, pick there, up to last. Sure, 1 centimeter there. Grab this, move this over here, exit out, go here, go to countersunk, 2 down, 818-degree angle, hit OK. All right. Or click the face, go to Sketcher, draw yourself a hole, circle, pocket, up to last, hit OK. Then you come over here, there's a chamfer tool, which we haven't talked about yet. You pick that, and I say how much do I want that? 0.2, 45 degrees, sure. Hit that, and there was that. Okay. Next one, hit this, position sketch, move this over here, exit out, 1 centimeter type, counter drilled. Well, this is going to look kind of weird, but 1.5 with a depth of, sure, something like that, just to get it done. So there's that. Sketcher version of this. Click here, make yourself a circle, come over here, go like that, exit out, pocket up to last, pick the face again, go to the top, make a circle, put it right in the middle. Oh gosh, how do we get it in the center? Well, okay, we can go here, we can pick this, then we have to say concentric, right, so it'll align nicely. Of course, you'd have to, I was skipping that before, you'd have to put in the radius or the diameter of the thing. You have to click this, and one, sure, take that, exit out, pocket that dimension down, 0.2, so there's that. Then I'd have to get in there with a chamfer, pick this, and oops, do something like that. That's the quick fast. We'd have to keep an edge there to do it exactly, but do you see how much more work we have to do? So you choose right time, right tool, right time, right? Also, maybe you would think, well, it's easier right now to make a hole right through this. I'll just use a pocket and pocket it down. And then later down the road, you have a meeting, customer says, oh, all those holes you just made for me, we're going with countersunk fasteners now. So could you just please quick fast just change that? And now you're like, oh crap. Now I have to go counter, now I have to take these and I have to chamfer 150,000 fasteners, you know, if you're, you know, aircraft or something. It might be a lot easier if you just had to change one, you know, hole tool here, something like that maybe, you know, or any of the others styles. Okay, so let's call that good for the hole tool. Done with that, and then I will go over the solid combine. Alright, so this is going to be a quick fast little video on the solid combine tool. I just decided in the last video doing the hole tool that what I'm going to do is some of these tools, and maybe all of them, I'm going to go through and have the quick fast version of all of them along with the tutorial version of them. So for those of you that are or were watching the hole tool, this will be at the end of that video. That'll be a part of that, just to knock it out, since that's what we were working on going through all the sketch-based features. Those of you that are looking at the quick fast section of the playlist, this will just be a short little, probably 5-minute video. Alright, so to get this started, the solid combine tool requires two things. It's going to be a sketch on a plane somewhere out here, and then a sketch on another plane, typically, you know, at some angle. In this case, we'll just do 90 degrees away from it. It's pretty interesting. Let me get it set up here. So the first thing you want to do, going with our established design constraints from before, we want to make a planes geometrical set, because we're going to make some planes. Duh. So go here, pick that. We'll make this 7 millimeters or centimeters away. Turn this direction. Grab a plane, stick it out there 7 centimeters, and there's that. Okay, so far so good. If you want, you can come back here and define this in work object. It kind of doesn't matter too much in this case. So what we're going to do is go on this side here, and we're going to make a shape. So I'll just use the profile tool, make some crazy looking shape. How about like that? There we go. Done. Okay, then I come over here and go onto this plane, and I'll use the spline tool. This makes the curvy shapes. Now, by the way, if you go to end this here, I can either double click or I can just right click and I can say close spline, and it will close it and make this a nice tangent seam right here. You can, as usual, move this around, change how you like. Exit out. Now we have our two shapes. The neat thing about this, what it does is, now you hit solid combine, and we say, here's this sketch. It's going to go this way. This one here going to go that way, and what it's going to do is make a solid where the two sketches intersect. Right, so if I look at there's that sketch, then I look at this one, and hey, look, it matches on both sides. Like, wow, that's weird. So we exit out, or zoom out, and then we hit OK, and then there's our shape. Solid combine. Okay, notice how it absorbs the two sketches over here. The planes are all separate. Let me get rid of this. Do it again. You make your two planes. Pick one, go into Sketcher, make a shape, make another shape over on the other one. I'll purposely make this one a little bit smaller than the other shape over here. Okay. Two shapes, solid combine, pick this, hit that, the two go together like so. Only where the two intersect. So that's it for the hole tool and solid combine. Sorry if the solid combine was a little bit weird at the end there, but it was sort of the last junk drawer item to catch on the list going through all of the sketch-based features. So thank you for watching, and I'll see you next video.